So in Lean Six Sigma, hypothesis testing is a statistical method used to validate or refute an assumption about a process, okay? And it also helps practitioners determine if the observed differences or changes are statistically significant, supporting the data-driven decision-making in process improvement. Okay. So this is a simpler word, right? Claim. I want to make a claim that when I buy a new machine, this machine will perform better than the old machine. This is my claim. Can your claim be always 100% true? Type yes or no in the chat box. Can your claim be 100% true? I asked the word 100%. It cannot be 100% true. Okay. How many of you are married here? Type MAR in the chat box if you are married. Okay, right. Thank you very much. Now, I'll ask you another question. How many of you are love marriage? Okay. Just send a love in the chat box. If you are a love marriage, just send this love emoticons in the chat box like this. How many of you are love marriage? All right. Okay. Now, the reason that I'm asking this is you made a claim, you make some assumptions that whether your wife or a husband, Mercy saying I was right. Okay. The hypothesis, the claim, okay, the assumption, the view, I'm using all alternate terminologies, was that it'll be a successful marriage for a long time. Yes or no? Type yes in the chat box. That was your claim. That was your hypothesis. Will that hypothesis be 100% true? Yes, of course. Many times. I'm asking whether it's 100% true. It cannot be. There is always a risk. There is always an iota of risk. But I wanted to ask you this question. How much percentage of risk are you willing to allow? 5%, 10%, 15%? How much percentage, 1%? How much percentage of risk are you willing to take? 5%? All of you type 5% in the chat box, okay? And that is what I'm going to explain called as p-value. Because even if you are making a claim about something which is true, there is always a 5% chance that it might go, your claim might go wrong. If this is super clear on a scale of 1 to 10, please give me a 9 or 10 if you found so far this illustration interesting, useful, fantastic, awesome, having fun. Just type it in the chat box, okay? All right, because this is a very dry subject and people will run away if you take hypothesis testing, okay? This particular hypothesis testing comes in a very important phase of Lean Six Sigma called as an analyze phase, because you wanted to validate a claim. Okay? Now, the objective of this is this. Data analysis is important. We'll discuss the importance of this. There is also something called as an estimation and comparison. We'll discuss the concept of that. And there's something called as inference about the population. All of you type IS in the chat box, which is inferential statistics. Okay, descriptive statistics and inferential statistics. Descriptive statistics will describe the data. What is the description of the data? You have an average, mean, median, mode, the central tendency, okay, and the spread of the data, which is variation or standard deviation. Okay, so descriptive statistics will describe the data, its central tendency and spread. Central tendency is mean, median, mode, and spread is variation or Six Sigma, whereas inferential statistics is to infer something, infer the population from a sample. All of you type PS in the chat box. P stands for population, S stands for sample. For example, during the exit polls, it is only the sample. And they'll say, oh, this party will win or that party will win. That is a sample. From the sample, they'll infer whether that huge party, the voters' results, right? So that is called inferential statistics. All right. Now we will describe the hypothesis testing. We will talk about alpha and beta risks. We'll talk about confidence intervals. We'll talk about p-values. I've already introduced the p-value a little bit. Okay. And then how p-values and confidence interval are used in decision making. And we'll have some real world examples. Okay. How many of you are excited to learn? Type ETL in the chat box if you're excited to learn. Okay. All right. Superb. I see so many people. Whoever is excited to learn. Okay. What I want you to do is join this world's largest community of lean champions. And also, I wanted you to join the upcoming webinar. Okay. Let me also share that link with you. Okay. Now, why is data analysis important? There are two types of data that we see here. Okay. One is passive and active. All of you type PA in the chat box. Passive data and active data. Passive data is sampled from a process. Okay. Or a historic data. Whereas active is after a modification is made in the process, you take the passive is either the current state or what has happened to the process. And active is what is happening to it after some intervention has happened, improvement has happened. So this is a passive data and active data. Okay. Provides objective solutions to the questions which are traditionally answered subjectively. Okay, gut feel. So from the gut feel is a claim, right? I think this girl will be good for me. This is a gut feel. I think this job will be good for me. This is a gut feel. I think this country, studying in this country will give me a future. That's a gut feel. Okay. That's all hypothesis. Okay. I'm going to share with you an interesting story. How many of you want to listen to interesting story? Type BIO. Bring it on in the chat box. This is going to be a very, very interesting story. Okay, before I share with you the story, I wanted to hear something from you. Okay, already I asked people who are married. I had made a note of people who got married and people who are yet to be married or ready to get married also. You will know what I'm going to ask you. Okay. Now you'll have to give me an answer in days, number of days. Okay. You should give the answer in number of days. Okay. Now, people who are married, who wanted to have a child, how many days? Think carefully and answer in days, not in months. Okay. Answer in days. How many days will it take for the girl, once she gets pregnant, to deliver a baby? How many days will it take? 270 days? 279 days? 270 days? 279? Somebody says 365. Somebody says 50 days. Okay, some people are having fun anyway, or they are ignorant about. Okay, fine. Thank you very much for sharing. Okay, so what is the range? If you can put the range for a human baby, okay? I'm not asking about cats and dogs, okay? What is the range? Somebody says depends. What is the range of the number of days that the baby will be born? 270 to 280, 210 to 270, 240 to 300, 230 to 280. All right. Okay. Thank you very much for sharing this. There is a reason why I'm asking this. Okay. Let me share this presentation with you. A short story about this data. Dear Abhi, you wrote in your column that a woman is pregnant for 266 days. A woman is pregnant for 266 days. Who said so? I carried my baby for 10 months and 5 days, which is 305 days that I carried my baby. And there is no doubt about it because I know the exact date my baby was conceived. Because I'd marked the date my baby was conceived, found positive, and then the baby's birth, and I calculated and I carried my baby for 10 months and 5 days, which is 305 days. My husband is in the Navy, and it couldn't possibly have been conceived at any other time. My husband is in the Navy, and it couldn't possibly been conceived at any other time because I saw him only once for a day and then see him again until the baby was born. I don't drink. I don't run around with guys or whatever. And there is no way that the baby isn't his. So please print a retraction about this 260-day carrying, because otherwise I'm in a lot of trouble. San Diego reader. Okay, now if this case for her is clear, on a scale of 1 to 10, please give me a 9 or 10 if this case is clear. All that is saying is, look, my husband came only once to my house because he's working in Navy. I got conceived on that day. From that day to the time that I delivered the baby, I've not met any other guy. It took me 305 days to deliver a baby. How the hell are you saying it is 266? Otherwise, people will start doubting me that I've gone with some other guy because they know when my husband came. If this is clear, type SC, super clear, in the chat box. Now, this is what is. What would you say to her and to her husband? Okay, that is the question here. Now, how many of you found this case interesting? Type INT in the chat box. I really wanted people to understand this and find this interesting, because this case was designed to help you understand the rest of hypothesis. I'll take hypothesis in 2 modules, okay? Now, analyzing the issue. The average carrying time is, average is okay, but can everybody deliver to the exact average? Can everybody perform to the exact average? There will always be variations, right? How many of you agree with me? Type agree. If you super agree with me, type super agree. You cannot deliver. The average conceiving time is 266 days. Everybody cannot carry the same average. It will be plus or minus. But how much is that plus or minus is the question. How much is the plus or minus that you will give? 10%, 20%? How much is that plus or minus you will give for carrying the baby? If she reports a 260-day pregnancy, would you be suspicious? Yes or no? Type yes or no in the chat box. Instead of 266, somebody says 260 days pregnancy. Will you be suspicious? So most of you say no. Okay. If she reports 400-day pregnancy, would you be suspicious? My question here is, what is the bandwidth that you will allow so that you are not suspicious? Let us see the bandwidth of people. 210 to 270, 260 to 280, 240 to 280, 230 to 280, 260 to 290, plus or minus 15 days. Okay, right. That's okay. Thank you very much for all your this thing. I think the number of people who type are serious people. Otherwise, some people are having fun with some numbers. That's fine. You'll find all sorts of people in this group. Okay. Now, at what point should you start becoming suspicious and make a mark? Okay. Now, this is what I wanted to illustrate to you. You have x-axis, which is you show the reading from 220 to 300. Okay. And the average is around 266 here. And she's reported worried in San Diego when she is in 305. Okay. Now, the background is the doctors have known for a long time that the natural childbirth has the following characteristics. Okay. The average is 266 days and the standard deviation is 16 days. So average and the standard deviation is called as the descriptive statistics of the data set. All of you type DS in the chat box. The descriptive statistics has two main things. One is called central tendency. The second is called a spread. The central tendency is mean, median, mode. The spread is standard deviation or variance. And that descriptive statistics is what we will infer in the inferential statistics, whether the mean is really the target value, the means are comparable, whether the variance is target value, whether the variance are. So in the inferential statistics, we will validate the descriptive statistics results. If this is clear on a scale of 1 to 10, type super clear in the chat box. That is enough if this is clear. So far, if you found it interesting, valuable, useful, fantastic, awesome, put it in the chat box. Let me draw some inspiration from your comments and proceed with the session today. The empirical rule. Because this is a very, very dry subject and people's mind will roll over. If you don't have logical and mathematical brain, it'll start rolling over. Okay. So I wanted to make it a little interesting with some interesting case studies. All right. Now, the empirical rule is this. Okay. We all know that any distribution will form. What is this distribution called? This is a question to all of the people who have attended my earlier session. What is this distribution called? ND, normal distribution, a bell-shaped curve, right? A bell-shaped curve. Now, what is the characteristic of a normal distribution? We have discussed in one of the modules that if you have the spread, this is called as a spread, okay? And the center is called as the central tendency, mean, median, or mode. In an ideal normal distribution where you have got the center as 0 and the spread in sigma plus or minus 1 sigma, 2 sigma, 3 sigma, okay? If you see here, 99 to 100% of the observations, okay, somewhere about 99.973 will be within plus or minus 3 standard deviations, and 90 to 98 will be plus or minus 2 standard deviations of the mean, okay, whatever is the mean is, okay, and plus or minus 1 standard deviation of the observation. Okay, we have actually explained this in the earlier module. Those of you who know it, type KNOW in the chat box. Okay, when you calculate the sigma, sigma is calculated using the value. Okay, and in an ideal normal distribution, within plus or minus so much of sigma values, like plus or minus 1 sigma, 60 to 65% of the observations will be there. This is the characteristic of an ideal normal distribution. Okay. If you don't understand this, don't worry about at all. I'll give you how to access my videos. You can see my videos, you can learn it, but stay on focused. Okay. So hypothesis testing is like this. There is something called as null and alternate. All of you type NA in the chat box. A null hypothesis and an alternate hypothesis. I'll tell you what is null and how to interpret this null. Okay. So hypothesis testing means you're claiming something. Okay. You're validating some claim. That is called hypothesis testing. It will help you to handle uncertainty, minimize subjectivity, question some assumptions. It will challenge some assumptions. Okay. Minimize subjectivity. It will handle uncertainty and prevent the omission of important information and manage the risk of decision errors. Okay. Okay. Now, Q&A session, a question. What is the purpose of hypothesis testing in Lean Six Sigma? To identify root causes without data, to validate assumptions and support data-driven decisions, to eliminate errors from the process entirely, to visualize data trends only. Okay, from whatever I've explained, what would be the right answer? Excellent. So to validate assumptions and support data-driven decisions, I think a lot of you were attentive. Fantastic. Okay, good. So I've impregnated some questions into this. Okay, so the overall approach will be this. In Six Sigma, the earlier modules I've written, why is the outcome or why is the effect, which is the function of causes. That's what we call cause and effect, right? So why is an effect? which is a problem. Undesirable effect is a problem, which is a function of causes. There are multiple causes, x1, x2, x3, x4. If this is clear, please type SC, super clear, in the chat box. Okay, now you have to understand this. Now you have to understand this. I'll help you with the overall approach step by step. A practical problem is converted into statistical problem. A practical problem is converted into statistical problem. A statistical problem is converted into a statistical solution. And then the statistical solution is converted into a practical solution. If you liked this, give me a thumbs up in the chat box. A practical problem is converted into a statistical problem. PP to SP, SP to SS, SS to PS. PP, SP, SS, PS. Okay? That's how. Now, Dr. Murali, how do we do this? For those who are not following this, don't worry. Just stick on here. This is not an easy subject. It requires some sort of logical background. But I can guarantee you, this is a learnable skill. And if you stick on, I'll make it interesting for you. Okay. And also join my upcoming webinar. It's going to be interesting. So the hypothesis testing is, as I said, null hypothesis and alternate hypothesis. We have typed any in the chat box. H naught is called null hypothesis and HA is called alternative hypothesis. And P value is a probability value. What is the probability value? P value is nothing but I make a claim. Null is already means no difference. All of you type ND in the chat box. Nothing has changed. Everything is status quo. Null is equal to ND. Null means no difference. So I make a claim that the new machine is not different from old machine. I make a claim that this party is not better than that party. I make a claim that this sample is no different from the population. So null means that is called null hypothesis, which is no difference. And even in the null hypothesis, even if you prove that there is no difference, there is always a 5% error. Okay, that is called p-value, which we are going to fix it as 5%. Good. Okay, now the logic is presume there is no difference. And once we claim that there is no difference, we need to provide evidence that there is a difference to reject the null hypothesis in favor of alternate hypothesis. So we will not say accept alternate hypothesis. We'll say reject null hypothesis. We have to presume there is no difference. We'll have to provide enough data that there is a difference to reject the null hypothesis. If this is clear on a scale of 1 to 10, please give me a 9 or 10. And I'm sure not all will give 9 or 10 because this is not such an easy concept to digest. I'm glad that many of them have given 7+. That itself is a big success, okay? Because it's not an easy subject that you can grasp easily. Okay, the question and answer session. So null hypothesis testing. What is null hypothesis testing? Null hypothesis in hypothesis testing. It suggests there is a significant effect or difference. It assumes there is no effect or difference. It proposes an alternate theory and it is used to confirm alternate hypothesis. What's your answer? Right. Whoever has typed B, send them a lot of chocolates. Now the practical problem. What is the practical problem that we have here? Okay. The practical problem is the null hypothesis is age isn't a factor in company hiring practices. Okay, suppose if you say age isn't a factor, what is the alternate hypothesis? Can somebody put it in the chat box? In hiring practices, age is a factor. Correct. Fantastic. Okay, fine. This is how is the alternate. You'll have to, this is a very simple. Alternate is the opposite of null. The product mix is same in all European countries. Okay, what is the alternate hypothesis? Same means there's no difference, right? Is not the same or different, we can say, right? Fantastic. Okay. Is different in some countries. Okay. Now, the delivery of company A and delivery of company B is the same. That is a null hypothesis. What is the alternate hypothesis? I'm sure all of you will type. They are not equal, they are different. Okay, either. And not equal can have three things. Okay, it's not equal means it can be less, it can be more. Okay. Okay. So you have to state your null hypothesis and alternate hypothesis. Let us continue with some more examples, okay, to understand null hypothesis. Now we'll see that, okay, average of group A is equal to average of group B. What is the alternate hypothesis? The average of group A is equal to the average of group B. It's not equal to, right? Okay. Let's see how many of you answer this. The slope of the line is 1. Okay, not equal to 1. Fantastic. Okay. The variance of group A is equal to variance of group B. Of course, you will type not equal to, okay? Okay, now look at this. Variable Y is independent of variable X. What is the alternate hypothesis? E is dependent, right? Fantastic. Okay, so these are all just to juggle your mind with what is how to see the null and alternate hypothesis. And hence, what we are saying is we need to convert the following statements into a hypothesis, H0 versus HA. You'll have to answer a question. A change was made to reduce the patent approval process cycle times. Let me give you some practical example. Okay, there is a patent approval process cycle time. Patent approval process, every process will have a cycle time, right? The patent approval process has a cycle time, and there was a change there. Okay, now the question here is, has the change affected the number of patent applications? Okay, how do you state the null and alternate hypothesis? I'll give you 1 minute. How will you state the null and alternate hypothesis? Let's see if somebody can attend. A change was made to the patent to reduce the patent process approval cycle time. And now we need to see whether it is, what is the null hypothesis? State the null hypothesis. Great. I'll just pause the chat for some time and reveal you the answer. The first thing is the average, the number of applications, the average number of applications of the new approval process and the old approval process, the application hasn't changed, the number of application hasn't changed, and the alternate hypothesis is the number of application has changed. Okay, now, similarly, one more question, okay? Our customer exhibit considerable variation when they pay their bills, okay? The new policies provide incentive to customers who pay their bill between 15 days, okay? Because generally bills are not paid on the time and they pay within 15 days. Now, what we have done is we have changed the policy so that we need to find out whether there is a variation in the bill payment, okay? The variation has to be reduced, right? So the null hypothesis is the variation. We can also say variation or standard deviation of the old and new is the same, which means that there is no improvement in the new process. Or we can say that the new process is taking less time or less variation than the old process. Okay.